Hey everybody, in this lesson we're going to be talking about how to rationalize denominators when we're dealing with fractions. We've already explored what to do with radicals and how to simplify square root. So just a little quick recap on what we talked about in a previous lesson before. Square roots are the most common in mathematics. We have a little 2 on the outside, but they don't really write it most of the time. So the squared root is called the square root because there's actually a little 2 on the outside of the radical that they don't write. Since they are so common, we omit the little number on the outside and just assume that it's there, but we don't really write it for the most part. So there is a little 2 there for square roots, but we just write it without the square, the little 2 on the outside. So this will be like the square root of m. But just assume that there is a 2 on the outside. So we've already explored how to simplify these. These are the list of square roots. So the square roots that we have here are all the way to 15. So from square root of 1 all the way to the square root of 225, which is 15. So you should know this already. If you don't, you should like jot these down and try to memorize them if you can, because they're the most common in mathematics. Okay, the only thing you need to remember for this lesson is the following. So these are the rules that you need to know in order for you to be able to rationalize the denominator. So first thing you need to know is, number one, radicals of the same root can be multiplied together, just like any other number. But their answer still remains under the same root, right? So the answer remains under the same root. So that's one thing you need to know, that it is possible, you can do it, and we're going to do some examples right now. Second thing you need to know is that fractions with radicals on the denominators are considered not simplified. So you actually have to go an extra step to simplify by rationalizing the denominator, which is the topic of this class. So essentially, this is what we're talking about. So let's say I write a fraction, right? Let's say I write a fraction as 5 over 10. If you look for that answer in a math book, it will not be there because technically speaking, in mathematics, that is considered not simplified. Most of the time, you would have to, what you would have to do is basically simplify it a little bit by dividing the top and bottom by the same number. Obviously, that would not be 2. My bad. Divide by 5, divide by 5, which would be 1 over 2 as our final simplified fraction. Same exact idea. So 5 over 10, it is the answer. However, it is not the simplified answer. What we actually want is 1 over 2. Same idea here. When you have a fraction, if you have a fraction that looks like this, square root of 2 over 5, and there is no radical on the bottom, then you're okay. But if you have another fraction, let's say, for example, 5 over square root of 2, you cannot have a radical on the bottom. That is considered not simplified, and this is not okay. So that's what we're talking about when we're talking about rationalizing the denominator. That all that means is we're trying to figure out a way to get rid of that radical on the bottom so that it's not there. As long as the radical is not there, we're basically good to go. It's considered simplified. Okay, so that's what we're going to talk about today. So let's go over the first rule real quick. The first rule that I went over basically explains this. It says that if you have square roots, you could actually multiply them together just like any other number. The only thing is that you still have the answer under the square root, under the radical. For example, 3 times 5 will give you 15. So the answer for this problem will be the square root of 15. Simple enough, right? 3 times 4 is equal to 12. The answer for this will be the square root of 12. However, for the square root of 12, we could actually simplify this a little bit. You could actually simplify the radical by doing the factor tree. So for example, this will be 4 times 3. This will give you 2 times 2. As you can see, for every 2 numbers, I take 1 on the outside. So the actual simplified radical expression for this would be 2 square root of 3. Okay, which another way of saying 2 square root of 3 is basically saying 2 times the square root of 3. Now, some of you guys that are smart, you probably realize, hey, I already know the square root of 4. The square root of 4 is 2. So looky, you actually get the same answer. This is actually the square root of 3 multiplied by 2, right? Which is the square root of 4. So the square root of 3 times 2 is actually 2 times the square root of 3. It's just written backwards. So the rule actually does work, and the rule actually allows you to simplify the radical a little bit if you miss one of those simplifications. That being said, if we have something like this, 8 times 15 times 3 times 5 times, if you multiply them all together, I don't know what that is off the top of my head, but it's let's do the calculator real quick. So 8 times 15 times 3 times 5. So 8 times 15 times 3 times 5. Calculator says 2,880. So that'll be the square root of, let me use a different color, the square root of 2,880. Now, you could actually go ahead and simplify this down if you can. Basically, what we're doing is we're trying to figure out, like if we can make this even the slightest bit simplified or not. So we can do the same thing on this side. For the most part, all you're really doing is you're basically splitting it up into what times what will give you that number, right? Which we kind of already know the answers here. We know for a fact that 8, I'm just going to go ahead and cheat a little bit since I already know what my four multiplications are. 8, 15, 3, and 5. We already know that those things multiply to get 2,880. But however, we can actually break down some of the other numbers, right? So 8 can be broken down as 4 times 2. 4 can be broken down as 2 times 2. So for sure, we can take at least the 2 out. 15 can be broken down as 5 times 3. And then, as you can see, for the simplification, we actually do have a pair of 5s. We have a pair of 2s. And we actually also have a pair of 3s from these circles, right? So we could actually take a bunch of this stuff out. So when we do the factor tree, for every 2 numbers that we have, we take one on the outside. So we could actually take out a 2. I'm going to write it right here on the bottom. We also can take out a 5, right? Because we have a pair of 5s here. So I'm going to write that times 5. And then we could also take out a 3. So times 3. And the only thing that's left under the radical is this 2 that doesn't have a little buddy to go out with right there. So I'm going to leave it as the square root of 2. So that's basically it, the final answer for this. Even though this is actually still correct, the answer is the square root of 2,280. We can simplify this a little more by simplifying the radical and multiplying everything all together at the end. So 5 times 2, it's 10. 10 times 3 is 30. So the final answer is 30 square root of 2, which is the exact same thing as this guy, square root of 2,880. Okay, now that we've done a problem as crazy hard or long, I should say, just to illustrate rule number 1, right? Radicals of the same root can be multiplied together just like any other number, but the answer remains under the radical. Check out what happens when the numbers are the same. So we have the square root of 7 times the square root of 7. That'll give me the answer as the square root of 49, which I could actually simplify by 7 times 7. I have 2 of the same number. That number goes on the outside. There's nothing left in the inside of the radical, so I'm basically just left with 7 because there's nothing left to put inside the radical, so it's gone. You'll see a pattern in a little bit. So now let's say we have 11 times 11. 11 times 11 is the square root of 121. The square root of 121 can be split up as 11 times 11. We have a pair of 11s. That means that we can take that on the outside. There's nothing left on the inside, so we're done. So really, really quick, without doing any work, you can start to figure out the pattern, right? So square root of 4 times the square root of 4 is the square root of 16. 16 is split up into 4 times 4. 4 times 4 will give you 16, and that gives you a pair, which actually gives you the number of 4. So what did we discover here? You should see a pattern, right? What we discover is that if you have the same number under a square root multiplied by the same number under the square root, then you get that number. Basically the square root goes away. Doesn't matter what that number is, right? It can be a happy face. So the square root of the happy face multiplied by the square root of a happy face is equal to just a happy face. The square root is gone. So same idea here. The square root of 150, it doesn't really matter if I know what the square root is or not. It's actually just 150. So what that means is the square roots cancel out when you multiply them together, and it saves yourself a lot of time and you realize this step. Why? Because when we're trying to figure out for rule number 2, how can we get rid of that square root in the denominator, right? This brings us back to our original problem. How can I get rid of that square root of 2 in the denominator? Well, one of the things that I can do is multiply that same exact value again to that number to get rid of that square root of 2. And then if I just do that same exact thing on the top, I'm basically not changing the fraction because I'm doing the same thing on the top and on the bottom. Therefore, this is called rationalizing the denominator, meaning getting rid of the radical. Okay, let's do some actual examples of rationalizing the denominator. So simplify the radical, square root of 9 divided by square root of 2. So what I could do here, I don't want this on the bottom, right? The square root of 2. So what I can do is I can multiply this by the exact same radical, square root of 2. I already know from my examples that that's going to get rid of the radical at all, basically for good. So I'm going to be left on the bottom with just the 2, right? On top, I'm still going to have square root of 9, but this time, whatever I do to the bottom, I have to do it to the top, so I have to multiply the top by the square root of 2 as well. Okay, whatever you do to the bottom of a fraction, you have to do that same exact thing to the top to keep the fraction balanced. So my final answer would be 2 on the bottom, the square root and the square root cancel out. On top, I get square root of 9 times 2. Square root of 9, I kind of know what it is, right? It was 3. So that will be 3 square root of 2 as my final answer. So the final answer, since I can't do anything else, I can't simplify, and I don't have any square roots on the bottom, I'm good. The final answer would be 3 square root of 2. All right. Hopefully it'll get easy in a minute. So same idea here. This is considered not a simplified fraction because we have a square root on the bottom. So if I want to get rid of that square root, all I have to do is multiply top and bottom by the square root of 3. The reason why I want to do square root of 3 is because I want to get rid of that square root on the bottom. So if I do that, on top, I'm left with 1 times square root of 3, which will just give me square root of 3. On the bottom, the square root and the square root cancel out, so I'm just left with 3. So my final answer is square root of 3 divided by 3. And then I can't simplify that anymore, so I'm basically done. And I don't have any square roots on the bottom, so I'm good. Example 3. Okay, I want to simplify this. Right now, it is not simplified because we have a square root on the bottom. Same idea. I want to get rid of that radical 2, so I'm going to multiply this by radical 2 on the top and on the bottom. If I do that on top, pretty simple, right? 5 radical 2. That's just that times that. On the bottom, the 2 goes away because it cancels out. So I'm left with 4 multiplied by 2. Whatever's left over, we multiply, right? So this actually becomes an 8 on the bottom. So the final answer will be 5 square root of 2 divided by 8. All right. Example 4, and the last one that I have for you guys. So this is it. We have to rationalize the denominator and simplify completely. Before I even start with this problem, I already know what the square root of 25 is, right? Square root of 25 is equal to 5, right? Because 5 times 5 is 25. So I'm going to go ahead and just go ahead a step further and just simplify that out. I already know that this is going to give me the value of 5. So I'm just going to go ahead and write in the 5 to save myself a little bit of time. On the bottom, I have 3 square root of 15. The problem is the square root of 15 on the bottom, right? I don't want square root of 15 on the bottom, so I'm going to multiply top and bottom by the square root of 15 in order to rationalize the denominator. If I do that, all I have to do is simplify and multiply everything out, and then I'm set. On top, 5 times 4 is 20, so I'm left with a 20 there. I'm also left with that square root of 15. Bless you. Thank you. On the bottom, I know that there was a 3 there. And then the square root of 15 and the square root of 15 multiply together, the radical will actually go away. So we're left with just the number 15. So there we go. Our final simplified expression is this. All we have to do is multiply everything out. So on the top, I'm still going to have 20 radical 15. On the bottom, 15 times 3, that will give me a 45. So my final expression is this. However, we should actually go a step further because, like I said, this is not simplified yet. This fraction can actually be divided top and bottom by the same number. It looks like we could actually divide top and bottom by 5, if I'm not mistaken. So we can go a step further and simplify that fraction. So 20 divided by 5 is 4. The square root of 15 is still there. On the bottom, 5 times 9 is 45. So there we go. I simplified the fraction. 20 divided by 45 is the same thing as 4 over 9. So this is my final answer. Since I cannot do anything else, this is considered my final simplified fraction. Okay, so that was a little quick tutorial on how to rationalize denominators when we're dealing with fractions. Okay, I hope this was useful. See you guys on the next one.